Okay, so this basic calculator 2, medium difficulty, given a string s which represents an expression, evaluate it and return its value. Integer division should truncate towards 0. You may assume the given expression is always valid. All intermediate results will be in this range. Not allowed to use any built-in function such as eval. S consists of integers and these mathematical operators separated by some number of spaces, so it's not going to contain like alphabetical characters or anything like that. It's always going to be a valid expression, and you can have the integers are non-negative, so you're never going to have anything negative. Okay, so looking at these examples here, we got s equals 3 plus 2 times 2. So we know when we got the 3, what we could do is we could have like a list, let's call it stack. So when we hit this 3, then we could like append it to the stack. Then you go to this character here, which is a plus. So you can say this operator is going to be a plus. Then you go to this here. So yeah, so it's number 2, so we'll append it to the stack. So then now stack equals 3 and 2. Then this here operator is a multiplication. Then this 2 here. So we basically, the previous number was a 2 and the current number is a 2. And then multiplication takes precedence over like addition or subtraction. So we want to evaluate this right away. But the issue is that what if you have like 25, right? We want like another, let's call this like 3205 or something. So we want another character or another iterator, like let's say like j. So that j is gonna start at 2 is integer, so now or is numeric, then 0 is numeric, then 5 is numeric, then it's non-numeric. So then let's call this like x equals s of I to j. So then we do the 2 times the whole 205. So it's going to be stack of the last element times equals to x. So that takes care of that. Let's look at this one here. So let's say this is like minus. Okay, so first of all, if it's a space implies skip, then minus here, so we could say like this operator is a minus, then we hit the 3, so that implies we want negative 3 to be in our stack. So stack equals minus 3, then we got the division, so op equals division, then we got this 2 here. So if 3 divided by 2 rounded down becomes a 1, we got this negative here. So again, we want 3 divided by 2 to be rounded down to 1 and then have the minus at the end. So what we could do is, because op equals division and stack of minus 1 times x less than 0, so it's negative, implies we'll do popped equals stack of minus 1, then we'll do the absolute value of stack of popped divided by absolute value of x, and then we do the minus 1 times all this. So that way we do 3 divided by 2, which is the 1, and then put the negative. So this will be negative 1 instead of negative 2. And looks like that's it. So we took care of all the possibilities. It could be either numeric it can be numeric consisting of multiple. It's not just a single digit, but multiple digits. It could be a plus times any other mathematical operator. It could also be a space. So looks like we can start decoding for this. So we got the stack, which is the empty list op. We'll assume this is positive because like here you got the 3. We're not going to call this a -3, so we call this a plus. And we always need to do the op before we consider what number we have. So if we start with a number right away, we need to know what the op is. So we assume it's plus. And then I equals 0 while I less than length of s. So if s of I is numeric, then while I less than length of s and s of I dot is digit. So as I mentioned here, we need another variable. We can call this actually I, and then we can call j the beginning of the multiple numeric strings. So it'd be the 2, for example. So we could say like this is the j, and then this is the I out here. So then we can do like the I plus equals to 1. And then, so here we can have like j equals to I. Then after you're iterating through getting all the numbers, then x would be int of s from j to I. And then, so what if s of I is not a digit? So like here, for example, it was a space, so we just skip it. If s of I equals a space, we just do I plus equals to 1. Their possibility was if it started with an operator, so let's say it's just -3 divided by 2, so then else so if it's not numeric or a space, we know it's got to be one of those mathematical operators. So if s of I equals plus, then op equals plus, and then now here we just do minus, then times, then division. And then we have to, of course, iterate I. Since they both have the I plus equals to 1, what we could do instead is just combine all of this into a single block. If s of I equals the division. And then, so that way if it's space, none of these will hit, and you're just going to iterate I. Okay, so now we got, so that takes care of this block. Turn sum of stack. Now we just need to take care of the cases where we have a number. It's like the -3. So here, the number's done. So to do this -3, to add this to the stack, we need to know that the previous operator was negative. And similarly, if this was like a plus or nothing, then we know we're just going to add the 3 to the stack before we consider the division. So I'm going to grab all this, and this is going to be op instead. So in this case, we just append the number to the stack. Same thing here, except because you have the minus sign, we're going to do the minus of x. Then we got times, as I mentioned here, we're going to do the last element of stack times equals to x. And then the division, So we know that if they're both negative, like let's say negative 3 divided by negative 2, then that's just the same as 3 divided by 2, which is rounding down would be to 1. So if stack minus 1 times x greater than equal to 0, then we know stack minus 1 is just going to be divided by equal to x. Else, then we got this little tricky case to take care of. Popped is the last element of the stack. Take the absolute value of it, divide by x, and then times it by minus 1, and then add that whole thing to the stack. And that should take care of everything. Let's make sure there's no simple errors like missing a semicolon or anything. Yep, this all looks good. So now we can walk through the code. So let's go through this one here. So we got the 3, I is 0, I is a digit, j is 0, I plus equals to 1. So now you hit the plus sign here, so you know that I equals to 1. Then you know that x goes from 0 to 1, so that's just a 3. The operator started as a plus, so we're just going to append the 3. And we're done with all this. So now I'll go back up here. S of I. So we're at this. I is there. I is not a digit. It's a plus, so op is a plus. And then iterate I by 1. So now you got the 2. 2 is a digit. This is I equals 2. Then I goes here, so I is 3. So the number from 2 to 3 is just the number 2. So now you're going to append that 2. And then you're done with all this. Now you go back up here. I is, I is 3. So we're at this multiplication. It's not a digit. It's multiplication. So now this gets hit. And then I plus equals to 1. So now I is at here, which is 4 is a digit. Iterate I by 1. So we're at I equals 5 now. That's outside this range, outside of length of S. So we're just going to do the 2 again. This time the op was times. So we're going to do times equals to the 2. So now stack is 3 and 4. And then the sum of that is 7. And then that matches this output here. So let's make this a little trickier. Let's say we got a minus here and a minus here. Okay, so we hit the minus, so then this gets hit. I plus equals to 1, so now we're at the 3. 3 is a digit, j is 1. I is the 3, so now I goes to here. That's not a digit, so done with I equals 2. So 1 to 2, so x is just the 3. The operator was the minus sign, so we go here. So we're going to do minus 3. Then we're done with all this. Go back up here. I is 2. So 2 is the minus sign, so we come back here and iterate I by 1. So now we're at this 2. So now I is 3. So now I is going to be 4. So 1, 2. Oh, so is this the 2? Op was minus, so we do -2 here. And then now, so I is 4, so we're done with all this. So I is 1, 2, 3, 4. So now it's the times. So this gets hit. Then I plus equals to 1. So now I is over here. 3, 4, 5, which is 5. And then, so this is going to be 2 again. The previous operator was a times. So then you're going to do the 2 times this -2. So this is going to be -4. So then the stack is -3 and -4. So the sum of that is going to be -7. And that's what we expect, because this should be 4, -3, -4 should be -7. So it looks like this code works. Wrong answer here. Let's see. Okay, so we got the 14, then the -3. So wait, so now we're at the 2 here. So okay, so at this point we know stack is 14 and -3. And we know x equals to 2. So -3 times 2 is not greater than or equal to 0. So now we pop out the -3. So 3 divided by the 2, which is 1, so -1. Oh, I said popped equals stack -1. I should say stack dot pop. Okay, so that should take care of it. So now stack is just the 14. Get the -3 out here. -3 divided by 2. Absolute value of all of it's going to be 1. So -1. So now you're just going to have 14 and -1. So that will be 13. And then, yeah, so that matches the expected output. Oh. So it should be the 3 divided by 2. Should be 1 and -1. So it's doing -2 instead. So there's something wrong with this division sign. Oh, I'm supposed to do the division here and then do the -1. And it passes everything. So that solves this problem. Thank you so much for watching.